Bonjour à tous, comment ça va? That's all the French I know, so from now on, the rest of the talk will be in English. My name is Martín Gontovnikas. My Twitter handle is mgonto, sorry, that's Spanish. I'm from Argentina. That's what I'm going to say now. So, I'm a software developer from Buenos Aires, Argentina. I'm currently employed by Acquicor Incorporation. And most of my day right now, what I've been doing is just JavaScript. So this is me all day long. I'm a machine, that's what I'm doing. So this talk is about Reactive Angular. What I did is just Google the trendier words everywhere. Angular was the trendier word in Google Trends, Reactive as well, so I thought, hey, let's put them all together. For sure, they will accept my talk. But that's not actually what happened. Let's start with the talk. So, besides working in the front end with AngularJS, I've also been working a lot with Scala. I've come to love Scala. I think it's really complex, but once you start learning it, because I think it's impossible to master it, it's really hard, but you start to love it. And once you start to love Scala, you start to realize that it leverages a lot in reactive programming. So I started loving reactive programming as well. I think it's really cool, and it has a lot of cool features. So this was me once I started meeting Scala and reactive programming. So I love Scala, I love backend, I love reactive programming, and I started thinking, can I use reactive programming in the front end? Can I use reactive programming in AngularJS? But let's start everything from the beginning. Let's start by understanding what is reactive programming. So I started asking in Twitter what people thought that reactive programming really means. The first answer I got was, I think reactive means something that takes decisions according to certain outcomes. So given an outcome, it takes a decision. Then a geekier friend, a techie friend, just gave me the attribute of a system that reacts to events. So I wasn't exactly happy with any of these definitions, so all I did was just go to the dictionary. In the dictionary, I read readily responsive to a stimulus. Of course, as every time I read the dictionary, I didn't understand it at all, so I read it again. Readily responsive to a stimulus. Still didn't get it. After thinking about it overnight, I started to understand that the most important thing about these 5 words is that it's a system that is always ready. That system is always ready to respond to something that happens, to an event, or to something that is going on. So once I started understanding that, I started checking out a little bit about the history of how computer programming and web servers and everything has been changed lately. So we used to have 100 servers for web applications. Can you imagine Google or Facebook having just 100 servers right now? We couldn't be able to enter right now. I guess that some of you are actually tweeting or Facebooking right now, so it wouldn't be able to do that. So now we have thousands or tens of thousands of servers. Also, we used to have gigabytes of data in all the servers, but now Facebook has, I think, 1,500 photos of mine, and I guess that it's the same for almost everyone in the world. Can you imagine saving those photos in just gigabytes of data? That's why they are using petabytes, or even bigger amounts that still don't have a word, maybe. We also have, like, hundreds or tens of users at the same time in one website, but lately the C10K started to appear, which is the concurrent 10,000 users at the same time, and that's what started people to think about how to create also faster web servers that can react, because now we have thousands and thousands of users at the same time. I want to be in Facebook chatting with a lot of people at the same time. That's why I have it. It's just gossip. So once we know a little bit about the history and about how everything has changed in all of these years, how the computer science, how the web has changed, I started to check out what are the main principles of Reactive. There's a website, Reactive Manifesto, done by the TypeScript people, which has a few of them, and also after reading a few papers from Odersky and others, I started checking out which are the main pillars. So the first one is that a system needs to react to events. What does it mean? If I am on a web page and I want to click a button, I want the website to do something. I want something to happen, because otherwise, why am I there? And this reaction to events allows the next pillars, which are reaction to load. A website needs to be able to handle a lot of users, because if it doesn't handle a lot of users, and for example, it's just a chatting website, why do they even do it? It needs to react to hundreds and thousands of users at the same time. Also, it needs to react to users. That means it needs to be responsive. Imagine I'm typing on Facebook, I'm talking to a girl because I want to go out with her. I'm typing her, and then she doesn't get the response, or I don't get the response from her. Then why am I on Facebook? Why am I talking to that girl if it doesn't react to me? I want a website that reacts to me and that does whatever I want. And finally, it needs to react to failure. Every time that Gmail fails, every a couple of years, you start seeing in Hacker News a lot of people complaining, hey, this is down, how can this happen? Imagine if every time one of the computers or one of the servers at Google went down, if the whole system went down. Everybody would be complaining all the time in Hacker News. Well, they're complaining all the time in Hacker News anyway, but more thinking that. So, now I understood the history. I understood how the computer science has moved forward, how the webs have moved forward. I understood the pillars of reactive programming, what it really means. And I started thinking, none of these things are new. Every time I go to a website, I always want it to react to a button click. I always want to be able to interact with that site. I always want to make a site that can handle a lot of users. I always want to make a site that can respond to users immediately. So, what's all the fancy talk about reactive programming? Why is it that trendy if everything is actually what we already know? After that, I actually started thinking a little bit more and checking out why it is so known and why it is so cool. So that's the main question I had at that point. And the answer, at least for me, is that it leverages functional programming to do this stuff, which makes it so easy for the developer and so easy for the programmer to handle these things that it didn't used to be that easy. So let's put an example. Imagine that, for example, I have a lot of threads going on in my server, because I have lots of threads, because I need to do a lot of stuff. And I have state. And those threads need to change that state of the application, that those threads need to change a variable. Normally, when programming, you would have to add logs, you would have to add mutex, so threads would need to talk to each other, and maybe we would lead to race conditions or some other problems that regular programming, let's say, can bring to us. So what's the cool thing about functional programming? For example, it embraces immutable states. That means that the state won't change. If it doesn't change, that means that my threads can work separately. They don't need to synchronize. They don't need to talk to each other. I don't need logs. I don't need mutex. So I will have less bugs, and it will be much easier to code with. At least for me, that's what reactive programming really means. It means that those pillars that were already known by us, they are easier to do, easier to work with by just using functional programming. So, now we know what reactive programming is. So that now that we know that, we can start asking ourselves, can we use reactive programming in the front end? Can we use it in somehow? So I started thinking again in the pillars of reactive programming. So I started thinking, do we have that stuff in the front end? And for sure, for example, for the first pillar, we do react to events. I mean, Front-end is mostly you click something and you do something else. So we do react to events. So let's start with a little example of how we actually react to events in our JS code. Let's start with a really easy example where we just have a button which each time we click it, it will count some amount. So we will have a counter that will increase each time the user clicks on a button. That amount will be answered by a server. So the first time you click it, it will say 1. The second one, it might say 4. The third one, it might say 7. So let's see how we would do it. In here, we have the example. The first thing we need to do is to set a global variable called counter, where we will keep on counting all these times that the user has clicks and adding new values there. Then, in this case, using jQuery, we will add an event handler for the click. And inside that event handler for the click, what we're actually going to do is to add all the behavior. So we're first preventing the default behavior, then we're calling our API server to get the counter amount. We want to get which number, what is the amount that we need to count this time. So once we get that response from the server, we are setting a callback there. In the callback, we're increasing the counter with that amount, and then we're just logging this counter to the server so that it knows what has been going on. And again, in the callback of that log counter, we're actually setting to the text the value that was not just logged. So what does it mean? Going back to the beginning. First, we have a global variable. Second, we have side effects, because each time that we get a click, each time that it enters this callback handler, it will change that global variable, so it will have a side effect. And the third thing is that we're starting to have what is called Callback Hell. We see a lot of spaces, a lot of tabs. That means Callback Hell, generally. Because in this case, we're actually nesting the callbacks one inside the other. So after seeing this code, I first saw that we're not handling errors. But let's say, okay, let's handle errors. Let's add that. If we would add the handling errors, we would have to add callbacks for error handling everywhere. One, for example, for the get counter amount from the API server, another one for the API server log. So we would need to add a lot of different functions or different ways of handling errors, and we will have it in several different places, even though we might just want one general error handler, which would do just one thing. Another thing we're seeing here is that we can't compose these callbacks easily. What does this mean? Each of these callbacks that we're adding here are really tightly coupled to what we have been doing. That's why we're nesting them. And that means that we can't actually compose them. We can't create easily in this way a generic callback that then we can join it together with another generic callback, and then we can build up something cooler. That is really hard with this approach. Also, there are no separation of concerns. If we go back to the code, we will see that in this line we have the counter, the call to the API server to save, then the log, and inside of all of those, we're changing the front end. That means that we're changing the front end exactly where the logic of our front end is, and exactly where we're doing the event handling. So we have everything all together, everything mixed up, and there are no separation of concerns. So I was really mad about it. I wasn't really liking how it was, so that was my face when I actually saw that code. So I started thinking, okay, let's check a reactive way of doing it. So this is, in theory, what I first came up. The first thing we're doing is getting a list of clicks from the button. What is this list of clicks? We won't have all the clicks from the beginning, so this will be actually an infinite list of clicks. That means that in this list, we will keep on arriving new events of clicks, and for each one of them, we will do something. This infinite list, sometimes called a stream, will just keep on getting new values. I will explain a little bit more about this a little further in the talk. And then for each of these clicks, for each of these different events that are going to go through this infinite list, what I'm going to do is just to add a chain of processing. What I'm going to add is that for each of those elements, I'm going to add a transformation, so that instead of getting an infinite list of clicks, I can get an infinite list of other things. So for example, in this first step, what I'm doing is, first, I'm calling the API server to get the counter amount. I will explain later about the observable.fromPromise, but the basic idea here is that I am, with this flat map, converting an infinite list of clicks to an infinite list of amounts. That means that I had empty events, void events of clicks, and that was a list, and now I will have an infinite list of different amounts. So for example, the first value will be 1, the second value will be 3, the third value will be 2. And those are the different values that I will keep on having in there. Then what I want to do is, for each of those values that are now part in the list, I just want to log them. So I would just log those changes, and this do for each will just output the same infinite list as before, but it will actually do a function. That means that this line does have a side effect, but this is the only line in our code here that actually does have a side effect. After that, I'm calling sum. What does this mean? This sum will convert these infinite lists of counter amounts to an infinite list of a single value, let's say, but that single value will keep on changing. So if we used to have an infinite list of 1, 3, 2, now we will have first 1, then 4, then 6. And then in this case, once we have this sum, I actually care about the value, because that's exactly what I want to show to the client. So at that point, I'm actually going to subscribe. I want to subscribe to this infinite list because I want to know what's going on at this point, at this particular infinite list. So in here, I'm subscribing, and then for each time there's a new value, I will get called in a callback. And in this case, I'm just console logging it. I'm just saying the count is this value. So basically, this is the same implementation as before. But in this case, for example, we don't see a var counter. That means that we don't have anymore a global variable. We still do have side effect, but it's actually very separate from the rest of the code. So the first time I saw this, I was really shocked. I think that at first, I didn't understand this whole concept of infinite list, streams. You're converting lists. I mean, how can it be infinite? So I really didn't get it that much at the beginning, but it seemed cool. At least that was at first sight. So as I was saying, clicks is an infinite list. But clicks is also a stream. But clicks is also an observable list. And now we will see why that is. So let's imagine that our infinite list is something like this. And we now get the first click. The first click is a circle. That circle is the first event that we're getting. What we are doing is converting that circle into a diamond. That diamond is now the counter amount that we have. And then we're converting that diamond to a square, which could be any other transformation. And now we have this square. But now a new click comes in. So that click will go through the entire process again. That click will be a circle first, then it will be converted to a diamond, and then it will be a square. That means that in the end, in the infinite, let's say, I will have a transformed list. So that means that in the infinite, I will have something like this, where at some point I have 4 clicks, which have happened through time. Those 4 clicks will be transformed to 4 different values through time, and then they will be transformed to other thing also through time. So this is how in time everything would happen, and this is what would happen if I go one by one. So what does it mean? As I've just said a lot of times, actually, clicks is a stream, which is an infinite list where new values keep on arriving. That means that this list will infinitely get new values for each time a user clicks on it or clicks somewhere. So what is the cool thing about this stream? That we can actually subscribe to that, as I've shown. We can actually subscribe to that at any point. And that subscription means that I care about the value. So I want to observe, I want to know what's going on in that infinite list. And that's why it's also called an observable list, because I'm observing what's going on at a certain point. And the function that I'm sending as a parameter in there is just an observer. So what are we doing again? We're transforming, merging, filtering every value that comes in into another thing, and we're getting another new infinite list. So, an important thing about reactive programming is understanding map and flat map. I was showing previously in the code that we have here a flat map, and I was saying that this is actually converting from an empty click, from an empty event, to a counter amount. That is not entirely true, and I will just show it now with a little example. But basically, the map, what it does is exactly converting one element to another. So if I have circles, they are being converted to diamonds. And the flat map, what it is doing is actually converting a circle, let's say, and then converting it to another infinite list. And what it's doing is actually merging all of those lists into just one. So for example, in this case, the flat map converts every circle to an infinite list of diamonds and square. That means that in the output, I will have just one infinite list with all of them, with circles, squares, and diamonds. So going back again to the example, what we will see here is why I'm using an observable. Because the server, in this case, is returning a promise. So what I'm doing is converting that promise to a new infinite list. In this case, this infinite list will just have one value, and that will be then merged into the main infinite list. So going a little bit forward about it, what are the advantages? That is one of the main questions. What are the advantages of doing the code like this if it's actually quite hard to understand how it works at first? First of all, we're handling errors in just one place. If I go back to the code, what you will see is that in the subscriber, I have a second function which actually handles error. That will handle errors for everything. I mean, if the promise didn't, I didn't get the value from the counter, if I didn't log it well, or for any error throughout the entire chain of conversions, we'll actually get in here, and that error will be propagated. That means that, for example, if the flat map fails, that error will go directly to this subscribe, and that error will be directly shown. What are the other advantages? We're actually composing handlers. As we saw here, we have very, very little functions which do just one thing. This is a very simple example, but the idea is that then these little functions, we can chain them all together, and we can create like a chain of transformations for these values, where from very little things, we can build up a very cool interface, and we can actually reuse most of this stuff. Also, we eliminated the Callback Hell. We're just creating a chain of transformations that we're running, but we don't see spaces, we don't see tabs anymore, so we eliminated the Callback Hell. So this, in the beginning, just blew my hat off. It actually blew my mind at that point, because I really liked how it was working. So, in theory, it's all awesome, but the question is, how can we apply this to actually real-world application, to real-world things? So, for that, what I've been using for some time is RxJS. These are the reactive extension for JavaScript. They are made by Microsoft, but trust me, it's not evil. that thing that was actually made by Microsoft, it is really cool. Microsoft was one of the first people to add observable lists and a lot of stuff about reactive programming in F# with Eric Meyer. So at least it seems they know what they are doing. That RxJS has versions for jQuery, HTML5, for whatever you want. But in this case, I will be using Angular, as that's actually what I've been using in my frontend. But the same applies to anything. So let's implement our counter now for real. In here, if I click on the button, I will see that the counter keeps on increasing. So at least it seems real. You don't know the code, but it seems real. So let's see how it actually is done. Our HTML is very similar to a regular Angular application. In this case, we just have an input type button. We have an ng-click with a function. In this case, the name of the function is increase counter. And then we're having a span, which actually shows that counter. And that's basically it. That's all our HTML. So let's go to our JS code. First thing we need to do is to depend upon the Rx module. Once we add that Rx module, we can actually start coding about it. Then, in our controllers, now our $scope has new functions that were added by Rx to the $root scope. One of them is the $create observable function, which takes the name of the function to create as a parameter. This name is the one that I put in the HTML. And this basically will create this infinite list, this observable of clicks. And to that infinite list, then I can start applying transformations. So what we will see now is that it's really similar to how it works in theory, because then I'm calling flatmap, and I'm using my API server that I injected in AngularJS. And what I'm doing is, as that returns a promise, and as AngularJS promises from $Q are A+ compatible, which means that they are compatible with any other promise in JS, I can just use this rx.observable.fromPromise, which will convert that to an observable. And what this will do is actually convert, as I said, that infinite list of events, of void clicks, to an infinite list of values. Then, for each of them, I'm actually logging them with these two. And then we see here the scan. This scan basically does the same as sum. What you will see is that it receives a function with the accumulator and the current value. And what I do each time is just add the accumulator plus the current value. And finally, I'm subscribing here. So I get in the subscriber the counter as a parameter in the function, and I just set it to the scope. Thanks to Angular bindings, every time this variable changes in the scope, it will change in the UI, in the HTML, and that's why every time I clicked, you saw that change. Also in here, I'm handling errors with console log. It's not really user-friendly, but it was a good example to show that I can handle all of the errors together in here. The cool thing about this is that even if the API server getCounterAmount failed, thanks to the observable.fromPromise, that error will be looped back through here, so I can even handle errors from the server. Like I got a 500 internal status error, I can even handle it here. I don't have to add a particular error handling for that. So again, I was pretty shocked because it actually did exist, and I actually could do this in AngularJS. So, that's not a real life example. I mean, who does a counter? Nobody. So, I thought in creating a more real life example. Let's imagine a contact search. I mean, most CRUD apps does have a contact search where you will search in the server and maybe have some local filters like the gender, if he's male or female or what he is. So here, for example, if I type O and I click on search, of course it doesn't work. Let's go again. If I click search, it will search all of the people. It will say in my case, name Martin Gonto, sex male. As you can see, my CSS abilities suck. So this is the most beautiful thing I've created, trust me. And now, if, for example, if I set a filter, for example, I want female, now it just returns the female. So let's see how we can actually implement this. First of all, here we see the HTML. Again, it's similar to any HTML that you would do with AngularJS. In here, we have the input type text with the ng model name. That will be the bidirectional binding with the search that we want to perform. Then we have the select with an ng model sex, which will actually show all the different options for male or female. And finally, we have an input type button, which will actually do the search. We're then iterating with an ng repeat over all of the different people, and then just showing the different results. So let's see the code, which is much more interesting. As you remember from before, again, we need to first include the Rx module as a dependency, and then we can start adding our infinite list of clicks. In this case, what we are doing is we're creating the observable function called search. What does it mean that the user clicks on search? It means that for me, for every time that the user wants to search, he wants to search something. So what I care about is what he wanted to search. So what I'm doing here with the map is actually converting that empty event of searching to a name that he wants to search. So now this infinite list will have, in my case, first an O, then, for example, Martin, then, I don't know, Sean, or any name. Then what I need to do is, for every one of those names, I need to go to the server and check it out. I need to go to the server and ask it, okay, find me a contact by name. And then it will return the list of all the contacts by name. Finally, what I'm doing actually locally is filtering those contacts. And what I'm saying is, if the user has entered a gender, then compare the contact gender to the gender that the user has inputted. I have it in $scope.gender. So now, an infinite list of 3 values has converted to an infinite list of 1 value in the particular example that I've shown. Finally, to that filtered list again, I'm subscribing to it, and then setting that list of contacts, that list of people, to the $scope.people field. That means that this will change, and as Angular binding works, my results will change together with this. I'm also handling errors here. This error handling will work if the filter fails, if the find by name fails, if the map fails. For whatever failure, it will go here as well. So, another very useful example is the Konami code. I mean, everybody wants to have an Easter egg in their application. So, another very, very useful example of reactive programming is just the Konami code. For those of you who don't know, the Konami code means you go to a website and you click left, right, AB, and it will show something amazing. There's actually a library called Konami code for jQuery which shows a dinosaur. So, I mean, you can see that it's really, really useful for real life. I think it was created for the Street Fighter, but I'm not entirely sure. So let's see how we will do it. First, what we're doing is getting all the keys clicked by the user as an observable. That means that for now, every time that the user clicks on something, that will be for me an infinite list. Then what I'm doing is mapping that infinite list of some key that was touched into the real, actual key that was clicked. For that, I do event.keycode. Then what I'm doing is, as the Konami code has 10 characters, I want to sum them all together by 10. So the first time this list will wait for the first 10 values, and then it will be creating every time new lists of 10 values each time the user clicks on something. So that means that I've converted from an infinite list of single characters to an infinite list of tens of characters, shifting by 1. That means the 10 and 1. It means that I will have 10 values per element, and I'm shifting by 1 to check them. Once I have that, what I'm doing is checking if that sequence actually equals the Konami code. That Konami code, I didn't add it here, but basically it's just an array of the key codes. That's all it is. So this will convert that list of 10 characters to a simple true or false. True if it matches, false if it doesn't. So then I'm just keeping the values that match, because if it doesn't match the Konami code, I don't give a crap about it. So I'm just getting those values that actually match the Konami code. And once I do that, I just subscribe and I show for, I don't know, 2 seconds or something like that, there was a Konami code clicked at some date. So with this, we have created the Konami code in a reactive way. I've just actually wanted to show it because it has different functions, not only the map, flat map, or scan. It also has, in this case, the window count. It has a different filter, and I just wanted to show that you can do a lot of stuff with the basic aggregations that already exist in RxJS, but later on, you can add whatever else you actually want. So RxJS reactive extension is just one example. What I want to tell you guys here is about using reactive programming in the front end. It can be done. I think it is cool. You will see a lot of libraries. There's reactive extension, this one. There's Bacon.js. There's React.js. And there are a lot more that actually do this same thing. Reactive extension is the one I trust and I love the most, but pick your own poison. And also, something important is that a lot of companies are actually starting to use reactive programming. As an example, Netflix was using reactive programming, so they created the reactive extension for Java, so that if you use Java, you can also use some of the concepts, some of the things that we have learned here. If you go to the reactive extension documentation or to the reactive extension in Scala, for example, you will see all of the methods that can be used. Not only some, you can reduce, you can aggregate, you can group them, you can make a fork join, because from one infinite list, you might be able to fork them, create 2 of them, subscribe at different places, show different things in the front end, and then merge them all together. Because as it's always an infinite list, I can subscribe anywhere. So that means that I can show different things in the front end at different points. So for example, if there's a loading, because I'm doing a lot of stuff, I can subscribe in the middle and say, okay, this is the current progress indicator, the current progress of what you've been doing so far. And this is just, as I said at the beginning, there's much more functions, and also you can create your own functions. You can create your own blocks that then you can reuse everywhere. For me, at least, the important thing is to create blocks that are small enough, but that they have the behavior enough so that they can be used or joined together with other things. So let's just react to everything. This is the end of the presentation. I hope you really liked it. Thank you again for listening, or at least pretending to. I really appreciate it. So this was Reactive Angular. So one more thing before the questions. I will be speaking in October in NG Europe. So here, if you plan to attend to NG Europe, you have a discount code, DevOps-2014, and you will get a 15% discount if you want to join. So thank you very much, everyone.